Chapter 3, describing data, numerical measure, numbers. How can describe? Central tendency and variation. Central tendency, for example, average score, distribution, and then where is center point, the extent to which all the data values group around the typical or central value. If data is like 10, 15, 20, and average is, later we'll do this one, 10 plus 15 plus 20 and divide by 3 equals 15. So if I draw out this data set graph, looks like this. 15 is here, so where is tendency, central tendency, where like a midpoint. The variation, the amount of dispersion or scattering of values. Okay. If there are two sets of data, first one is 10, 15, 20. How about 0, 15, let's say 30. This one's average is 15, this one's average is 15. The same central tendency, but if I draw two data set on graph, 30 here, 0 here, and then something like this, 10, 20, and 15. So same averages, central tendency, but dispersion wider, narrow, different. Measure of central tendency, we can use mean, median, and mode. The mean, arithmetic mean, the most common measure of central tendency, mean is average. Other values play an equal role, that means we have a data set 10, 15, 20, then average is 10 plus 15 plus 20 divided by 3 equals to 15. That is the same as 10 times 0.333 plus 15 times 0.333 plus 20 times 0.333. The same result. So to make average or mean, first one's roll, second's roll, third one's roll, the same, 0.3333. This 0.333 from 1 divided by 100% divided by 3 sample size. This is simple average. So roll of each member is the same. Okay. So like this, 5, 10, 15, use another example, then 0.333, 0.333, and so on. Okay. And balance point in a set of data. Central tendency is a balance point. And the sum of the deviation of from the mean is 0. Okay, if we have 5, 10, 15, 5, 10, 15, then 5 deviation from mean 10 minus 5. 15 deviation is from mean 15 minus 10 is 5. So deviation 10 is 0 because it's the midpoint, the average. So minus 5 plus 0 plus 5 equals 0. So the sum of the deviation, 5 is minus 5, 10 is 0, and 15 is 5. So deviation, sum of deviation is 0. Minus 5 plus 0 plus 5 equals 0. If we have a data set like this, total is 42. Average is 11 plus 4 plus 10 plus 4 plus all divided by sample size 42 equals 192. All divided by 42 equals 4.57. That is average or mean. Okay. Earlier, in chapter 1, parameter and statistic. Parameter from a population, statistic from sample. End of the, this chapter 3, I will talk about the parameter and statistic again. Anyway, if data set is population, then mean is denoted by, looks like this. We call this mu, mu. And data set is sample, then the same calculation, but denoted by x bar, that is sample mean. So if data set is sample, then the same calculation, add all of them, 39, 29, 43, and so on, divided by sample size 10 equals 396 divided by 10 equals 39.6. That is sample mean. Weighted mean, just a simple mean, each member's role are the same, but weighted mean, each member's role may be different. For example, our grading policy, attendance 10%, midterm 30%, final 40%, and then formative assessment is 20%. That case, if you get, you don't miss any class, then 100% of attendance, 90 out of 100 on midterm, 80 out of final, and then formative assessment 70 out of the 100, like that. Then 10%, 0.1 times 100 is 10. 30%, 90, 27, 40 times 0.4 times 8 equals 32 out of 40%, and 20 times 0.2 times 70 is 14. So cumulative, it's not cumulative, weighted average is 83. 10 plus 27 plus 32 plus 14, 83. So your grade, final grade, based on and depending on weight, and then your score. So this grading is not simple average. that is weighted average. So each one's weight different, then score may be different. That is weighted mean. For example, classic example, company pays its hourly employees $16.50, $19.25 per hour. There are 20 hourly employees. Total member is 26. 14 paid 16.5, 10 paid 19, 2 paid at 25. Then what is average wage? It will be 14 times 16.5 plus 10 times 19 plus 2 times 25 divided by total number 14, 10, 2 equals 18.1154. This is weighted average. Each member's 14, 10, 2, each member's role are different. That is weighted average. Next one is median. Okay, mean, average is middle point, balance point, arithmetic balance point. But this one, median, is physical midpoint, physical balance point. The middle value in a set of data that has been ranked from smallest to largest. Median equals n plus 1. N is sample size plus 1 divided by 2 ranked value. So if we have data, then first step is rank them. 19 from smallest to largest, 19, 20.8, 22.3, and so on. And then their ranking is first, second, and so on. Find physical location. Physical location. Where is the midpoint? Using formula n plus 1, n is 7, sample size, plus 1 divided by 2 equals 8 over 2 is 4. So, fourth ranked, this is physical location. 1, 2, 3, 4. Fourth ranked value is 22.4. Anyway, there is a rule. Rule 1, if there are an odd number, sample size is odd number, 3, 5, 7, 9, 11, and so on, odd number, then plus 1, even number, divided by 2 is whole number. So, no problem, just find that location and then value associated with that location is median. So median is 22.4. Fourth ranked value is 22.4. So when you take exam and an assignment, some students just fourth ranked value. But that is wrong. Should be denote this value. Okay, next rule. If there are uneven number, sample size is even number, then plus 1 divided by always 0.5, something 0.5. That case, find two adjacent numbers and average. So 0.5 ranked value, 0.5 is between. So take two numbers, 35 and 40. 39 plus 40 divided by 2 is median. when sample size is even number, then the result is always 0.5. Ranked value, that case, take two numbers, 0.5, 5.5, then between, take this and this, add, divide by 2 is median for this example. Next one, mode. The value in a set of data appears most frequently. Okay, here 29, 31, 35, 39, 39, 40, and so on. This number appear only once, twice, once. So 39 is most appear number. So mode is 39 for this example. Sometimes there is no mode. Every number appear only once. So there is no more of appearance numbers, so there is no mode. Sometimes multiple mode, 39, 39, 44, 44. Tie two numbers most frequent, so there are two modes, 39 and 44, this example. Practice problem number 15. This one is under course material document. Okay. The following is the percent change in net income from last year to this year for a sample of 12 construction companies in Denver. Determine the mean, median, and mode. Mean, just add all of them and divide by sample size. So, if this is sample, then x bar equals 5 plus 1 plus minus 1 plus minus 10 and so on up to last one 11 plus 11 divided by sample size 12. 1, 2, 3, 4, 5, 12. That will be, I have answer file. So that is 47 divided by 12 equals 3.91667. That is mean, simple one. And find the median. To find the median, first step is rank from smallest to largest. Minus 10, minus 6, minus 1, 1, 5, 5, 6, 7, 8, 9, 11, 12. Their ranking is first, second, third, and so on like this. Median, n plus 1. So 12 plus 1 divided by 2 is 6.5 ranked value. 6.5 is between, so take two numbers, 5 and 6. 5 plus 6 divided by 2 equals 5.5. So median is 5.5. And mode, up here once, twice, once. So mode is 5. Okay, variation. The range and variance standard deviation. Range is simplest numerical descriptive measure of variation in a set of data equal to the largest value minus the smallest. Range is the distance from smallest to largest. So largest minus smallest. In this data set, largest is 5229. So range is 52 minus 29 equals 23. That is range. And variance and standard deviation. Measure the average scatter around the mean. Maybe same mean but different because of how dispersed, how much distance, narrow and wide. That is variance and standard deviation. Population variance get certain number from population, that is parameter. Population variance, we read this one as sigma. Actually sigma looks like this. When we use sum of, then looks like this. That is sigma. This is upper case, lower case. Sigma square. Sum of, this one is sigma 2, uppercase. Each number minus mean and square, and then add all of them, divided by population size. That is population variance. Population standard deviation is square root of variance. So sigma population standard deviation, sigma equals square root of population variance. Sample variance, the same but different, as square. Sample variance equals sum of individual member minus sample mean and square divided by n minus 1. We call this degree of freedom. We will talk about degree of freedom later. And sample standard deviation, S, that is square root of sample variance, the square root of sample variance. Using a formula, we can find variance and standard deviation, but it's tedious. Later, I will teach how to get variance and standard deviation using Excel. So just to let you know how to get variance and standard deviation using a formula. But don't worry about it. So data 39, 29, 43, and so on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sample size is 10. Average is add all of them divided by 10 is 39.6. Then we need x minus x bar. X bar is mean. So 39 minus 39.6 is minus 0.6. 29 minus 39.6 is 10 minus 10.6, and so on. Then square of this one, then 0.36, 112.36, and so on. And then add all of them, 412.4 divided by 9, because sample size is 10, n minus 1 divided by n minus 1, 9. 412.4 divided by 9 equals 45.82. That is sample variance. Sample variance 45.82. Sample standard deviation is square root of sample variance. That is 6.769. Okay. Parameter and statistic. Number from population, that is parameter. Number from sample, that is statistic. Mean denoted by mu. Population mean. Population variance, sigma square. Population standard deviations, sigma. Sample mean x bar, sample variance s square, sample standard deviation is s. Statistic parameter. Practice problem question 51. You don't have to do, just look at this and then answer how to get standard deviation using formula like this. But just to look at it, you don't have to do, because we will use Excel later to find the standard deviation. So just to look at it. That's all for chapter 3. You have an assignment under week 2 assignment, assignment chapter 3, complete by due date. Thank you and see you next time.